we're looking at partial fractions and the format that the partial fraction is written depending on the type of denominator. This is page 746 of the book, the e-book, Pre-Calculus, Mathematics for Calculus, 7th edition. Now, this is case 1, when the denominator is of distinct linear factors. Linear factors meaning in the form of a number times x plus a number. Alright? A1, B1 are numbers. So here, this could be a situation like saying you have x plus 3 divided by, and then the denominator is it could be x times x plus 1 times 3x plus 2, right? When you're going to write this out as partial fractions, I'm going to say a over x, because x is the same as x plus 0, you know? So x is 1x plus 0. So x is still in the form a1x b1. They use a2 plus and then an, but I'll just use b and c, as is usually the case when you're working it out. So you're going to write this in the form a over x plus 0 plus b over x plus 1 plus c over 3x plus 2. Alright? That's the form that you will write when you are going to figure out what the partial fraction is. And then, of course, you would work out to find a, b, and c. Now, let's look at case 2. Case 2 is when you have repeated linear factors. It says the denominator is a product of linear factors, some of which are repeated. Alright? So, what they're saying is, suppose the complete factorization of qx contains the linear factors ax plus b repeated k times, that is ax plus b raised to the power of k. Right? So, what they're saying here is something like x plus 1 divided by, and you have 3x plus 2 cube. What you're going to have is a over 3x plus 2 plus b over 3x plus 2 squared. Let me write the 2 here. Squared plus c over 3x plus 2 cube. That's the form the partial fraction is going to take. Then of course you use algebra to work it out and find the values of a, b, and c. Alright? So that's what happened here. Now, here, case 3, the denominator has irreducible quadratic factors, none of which is repeated. Suppose the complete factorization of qx contains the quadratic factor ax squared plus bx plus c, which can't be factorized further. So that's why they say it is irreducible. You cannot factorize it. Then, corresponding to this, the partial fraction decomposition will have this form, ax plus b over that quadratic expression. So, it is something like you have x plus 1 divided by, you have x squared plus 3x minus 7. Alright? When you're finding the partial fractions, you say ax plus b divided by x squared plus 3x minus 7. Then you multiply out and so on, work it out as algebra, and figure out what is a and b. You have ax plus b over this. Alright? And then, case 4, the denominator has a repeated irreducible quadratic factor. Suppose the complete factorization of qx contains the factors. Then you have the quadratic ax squared plus bx plus c raised to the power of k, where ax squared plus bx plus c can't be factorized further. It is irreducible. Then the partial fraction decomposition of p of x divided by q of x will have the terms. So what you have is a number x plus another number over ax plus bx, ax squared plus bx plus c, plus you have another number x plus a next number over ax squared plus bx plus c squared, and so on. So suppose instead of x plus 1 over x squared plus 3x minus 7, what you had was x plus 1 divided by x squared plus 3x minus 7 cube. What you'd have to do is say ax plus b over x squared plus 3x minus 7 plus, then you have cx plus d over x squared plus 3x minus 7 squared. Right? See that? Then plus ex plus f over, and then you have x squared plus 3x minus 7 cube. And then you have to figure out what your a, b, c, d, e, f are. So those are just the general form that the partial fractions will take, the 4 main forms. But case 1 would of course be the most common, the most popular form that the partial fractions would take.